Alright, in this video we are going to be looking at similar kind of things we've been doing, operations on polynomials, so add, subtract, multiply. I guess we haven't done a whole lot of dividing yet, but we'll be doing those with several different variables. So instead of just having an x plus 4 uh, um, times something, we might have x squared minus x times xy minus 4yz. In other words, multiple variables, lots of letters. Okay, so let's get started with the first one. Oftentimes you'll see an expression like this one, and they're similar to formulas where you'd have different letters that represent different things. And if you want to evaluate those, again, the first thing I would do if I was evaluating this polynomial with plugging in some numbers, I would just rewrite the whole thing, and everywhere there's a variable, I put a bracket. There's an x and a y squared plus 8 times x cubed and y cubed. And then I go back later and plug things in. So x is a 2. Here's another x. Y is a negative 5. 8x, that's a 2. And y, that's a negative 5. And then I go back and do things in the right order. So I guess I can do these ones already. So 4 plus 6 plus. Now before I multiply these, I'd have to square that. So negative 5 squared is positive 25 times 2 is 50. Plus 2 cubed is 8. I can't do this one all in my head. And negative 5 cubed would be negative 125. Oh, great. Okay. So this will be, if I multiply this out, this will be about 1,000 times 8 would be about 8,000 with a negative. So I have 4 plus 6 plus 50 plus, I said negative 8,000. Okay, I don't have enough room to keep going, but then I will just add these. So that would be, what, 60. So I'd be 60 off of that, so 7,940 to the negative side. Okay, so that's how you can do that one. Maybe try this one on your own and see what you come up with. And then press play again and see if we're right. So 8 times x is a negative 1 times y is a 3 squared minus 2 times x is a negative 1 cubed times z is a 4 minus 13 times x is a negative 1 to the 4th, and y is 3 squared plus 5. Okay, hopefully I did all that right. That's a lot of plugging in that you have to be careful of. So here I'd have to square first, so that's 9. And 9 times 8 is 72, times the negative 1 is negative 72. Negative 1 cubed is still going to be negative 1, times negative 2 is a positive 2. 2 times 4, that part will be 8. Okay, minus negative 1 to the 4th is positive 1. I can't do this all in my head. That'll be a positive 1. 3 squared would be 9. And notice if you can't do stuff in your head, that's fine. Put more steps in. So now I'll have negative 72 plus 8. 13 times 9, what's that? 27. 117 minus 117 plus 5. So now I could collect the negative stuff together and collect the positive stuff together. So that would be 89, negative 189, plus, and the positive stuff is 13. So altogether, I'm hoping you get negative 176. That would be the answer for this one. Hopefully that's what you got. I might have made a mistake in there somewhere. There's lots of stuff that could go wrong, but I think that's pretty close. Okay, so that's evaluating a polynomial with lots of variables when you're given what those variables are. Here's an example. You can try this. I won't give you a number on it, but an example of number of calories needed each day, how much you weigh in kilograms, so many centimeters small, and so old. And so you plug those numbers in, and that'll tell you what your basic caloric intake should be for a day. Okay, now, when you have several variables, often we want to be able to classify that type of polynomial. And so we do that by something known as degrees. And the degree is the highest powered term of a polynomial. So if I take a look at this one here, I've got an x and a y both in the same term. The x, the exponent isn't written, but we know by default it's a 1. So what you do to figure out the degree of this term is you would add those coefficients. So this would have a degree 5, that term. This one would have a degree 7, yeah. This one would have a degree 3. This one would, since there's two 1s there, would have a degree 2. So totally this polynomial, oh, and this one here, there's no x's or variables there, so it would have degree 0. So when you look at it, the highest degree is a 7, so this one would be a 7th degree polynomial. If you were rewriting this in descending order, you would write this one first. So 3x squared y to the 5th, then you'd write this one xy to the 4th, etc. Try that with this one. Okay, this would be degree 3. This one would, oh, there's 3 of them. 5, 6, 7, degree 7, degree 1, degree 1, degree 0. So if I'm writing it, I'd put this one first, then this one, and then I guess it's a toss-up, between these two. But logically, it makes sense to put the one alphabetically first. So I'd put that one first, then that one, and that one last. Now, once we can see what degrees are, and when we're looking at the variables themselves, we can start adding things or simplifying a term. If I take a look at a polynomial like this, if I'm wanting to simplify it, I'm looking for things that are the same or like terms. This one has an x and a y, but so does this one, and so does this one. Which of the two are alike? The ones are alike only if the letters and the exponents are identical. So if I see this, that's not the same, but this one is. So I could collect those two. So I'm up 4 and I lose 2, so I'd be up 2x squared y's. There's nothing to go with this, so I would just write it as is. For this one, wx, there's a wx, so I can combine those two. Down 3, gain 8, so I'd be up 5 wx's. And then wxy cubed. There's one right there. So I'm down 5, I gained 5, so it'd be 0. So that those two terms would cancel each other. Gone. And now I'm down 12, different color, down 12 and up 4, so I would be down 8. Come on. Okay, so minus 8. That's it for that one. So try this one down below and see how you do. And then press play. Okay, so rs squared. There's another one right there. Whoops. Right there. So I'm up 6, I lose 7, so I'd be down 1, rs squared. Again, notice I'm using different color for this. That's always handy. rs, there's an rs. That's that last one. Down 7, lose 5, so I'd be down 12 rs's. And then finally, an rt squared. Oh, I don't have another one. That's the only one. So I would just write plus 3rt squared. Okay, hopefully you got that. Okay, so that was adding, well, that was, I guess, collecting like terms, and that'd be the same that you would do here. You would drop the brackets, then just look for the like terms and add their coefficients. So this one, 4 take away 8, you'd be negative 4 x cubed y cubed. Then you go on to the next term. Let me go, though, to subtraction. That's where the fun happens, right? When you have a minus in front of a bracket, that's our dirty, rotten, filthy, stinking negatives. That's how Steve Penny used to say it. So this one, you would leave this alone, t plus s cubed t squared, and drop in brackets s squared t cubed. Now I have to use the distributive property to distribute that minus throughout. So this is positive, so now it'll become negative 4s to the 4th t. This one will become positive 5s cubed t squared, and this one will become negative s squared t squared. Now you collect terms just like we did. This step here is the one that causes most headaches for students. So be careful with that step right there. And it's often this term that you mess up, or I guess those terms. Just be really careful with them. Here's another way of writing subtraction, which seems just a little bit funny, but you can do the same thing here. This is like this whole top thing minus the whole denominator thing, or the thing on the bottom there. But this here, this one right there is a dirty, rotten, filthy, stinking negative. So really what I would do is change this to plus, and then change the sign of everything that's inside here. This one would be a minus, and then this one would be a plus. Then, as long as they are like terms, you can add them. Negative 9, P4Q. This one, they're both positive, so it would be positive 9, P cubed, Q squared, etc. Okay, so just be careful when there's a minus, that right there, dirty, rotten, filthy, stinking negative, make sure you apply it to everything in that second bracket. Okay, next thing is multiplying. When you're multiplying these, just like we did before, you have to remember sign, number, and letter. So if I'm multiplying these two, I have to do the distributive property with this one. I'd have to go that times that times that. So p to the 4th cubed times p. If it helps you to sort of write it off to the side, p4q times p, you can do that. But really, you're multiplying signs, so positive times positive is going to be positive. And then numbers, there's no numbers written, so it's 1 times 1, which is 1, which we don't need to include. Then p to the 4th times p to the 1st, multiplying common bases, add their exponents. So that would be p to the 5th, and q, there aren't any q's here, so it would just be p to the 5q. That would be the first term. The next term, sign, would be a negative. Number, 1 times 2 would be a 2. And then p to the 4th q times q. There's no more p's on this one, but there is a q. Q times q, they each would have an exponent of 1, so that would be q squared. And that's that one. And then you'd go ahead and do this one, and that one. And then finally, you do this one and that one. Remembering every time to worry about your sign, the number, and then when you're multiplying common bases, add the exponents. We haven't done much dividing, but it would be the same kind of thing with this one. Again, you worry about sign, number, and letter. Positive divided by positive is positive. 20 divided by 5, those are my numbers, 4. Dividing common bases, subtract their exponents. So that answer there would be 4x squared. Try this one. See what you come up with. Hopefully you came up with a negative, a 28, and then p cubed and q to the 1st, or just q. Okay, now if you are dividing a polynomial by a monomial, like in this case, this is probably a nicer way to write it, but it's this thing on the top divided by that. This bottom monomial, it has to be divided actually into both of those. So writing it like this is one way you could write it. So each of these terms on the top must be divided by whatever's on the bottom. So writing it like this is a good way actually of figuring out the answer. Don't, though, just divide this monomial into one of those things up at the top like I did here. That's inappropriate. You can't do that. That has to go into both of them. So if I were doing it for this question, sign is going to be positive, number is going to be 7, divide common bases, subtract their exponents. Sign is positive, divide the two numbers into 8, divide common bases, subtract their exponents. Okay, so there's your dividing. Last, maybe we'll try this one as an example. So here I've got 3 terms divided by one thing. So I'm going to write it out as, I guess I could try and do it in my head. That would hurt too much. Let me just write it out. 2x to the 4th y is 6. I have to divide that by negative 2x squared y squared. Minus, I've got to take the 6x cubed y to the 4th divided by a negative 2x squared y squared. Ooh, 2 negatives. And then plus 10x squared y cubed divided by negative 2x squared y squared. So I have to take each term there and divide it by that one. Okay, so let's do the first one. Not sign, it's going to be negative. 2 divided 2 is 1. Then dividing common bases, subtract their exponents. Subtract their exponents. These are the same, so they cancel out. It's a factor of 1, gone. So negative x squared is all what I get from the top there. Next one, I have negative divided by negative, so that'll be a positive. 6 divided 2 is 3. Divide common bases, subtract their exponents, so x to the first. Divide common bases, subtract their exponents. Positive divided by negative is a negative. 10 divided 2 is 5. X squared divided x squared, factor 1 cancels. Y divided by y, subtract exponents, you get a y. So that would be the quotient of that division up there. Okay, so hopefully that helps you. Notice it's the same thing we've been doing before. It's just in this case we've had to deal with multiple variables. All right, try some questions.